Well, good afternoon and welcome to the Aquimetrics Webinar. My name is John Dustman. I'm the President and CEO of Summit Enviro Solutions. We're based out of Minneapolis, Minnesota. I see we have people from all over the country here. We've got utility operators, public works directors, water superintendents. We got bottled water companies, mining companies, irrigation companies. So hopefully I can answer any questions that you might have at the end of the webinar. But before that, we'd like to kind of roll out what we're trying to do here. We think we have the first ever real-time aquifer resource management. We've combined hardware, software, and services into a group of technologies that we're calling Aquimetrics. And what it does is it creates a smart well field. So with that, I'm going to just dive right in. Who we are, we're an experienced team of hydrogeologic professionals incorporated 30 years ago. We think we understand that groundwater issues are very complex and they can be frustrating for most of you because we can't see what's below the ground surface. We've had a great opportunity over the last 30 years as a privately held small company to develop these technologies because we didn't see them in the marketplace. We did build them completely in-house using our team of scientists and engineers. We do provide hydrogeologic consulting services to both the public and private sector clients in the water supply, remediation, mining, food and beverage, and agricultural market sectors. But it's important to know that we're not a software company. This technology was built by scientists and engineers. Do your water wells talk to you and each other? We built this to streamline and optimize well field management by completely automating the well field monitoring. The platform includes integrated hardware and software that is offered as a turnkey service by our professional hydrogeologists and engineers. The platform leverages the current explosion of Internet of Things technologies to collect, store, and analyze real-time and continuous groundwater data. We install sensors into the well, and they are used to collect information on water level, temperature, salinity, pH, conductivity, and other groundwater quality parameters. The data are then transmuted back to your SCADA system or through our telemetry system to a database stored in the cloud or actually anywhere else. Our software then performs the analytics for operational optimization and regulatory compliance. The result is a smart well field, or what we're calling a smart well field. The wells can essentially talk to each other and to you to evaluate what pumping rates are the most efficient for the current water demand and maybe more importantly, the aquifer status. By using your existing SCADA system or standalone variable frequency drives, the Aquimetrics platform can continually be determining and selecting the pumping rates at individual wells to optimize the well field performance. What is a smart well field? A smart well field enables operators to employ hydrogeologic principles to accurately make real-time and automated decisions regarding pumping rates, schedules, and well maintenance and rehabilitation events. Specifically, a smart well field is a network of wells where flow rate and water level information are continually analyzed to turn pumps up and down and on and off to better manage an aquifer resource. Over time, Aquimetrics generates a comprehensive data set of current and historical trends that depict aquifer conditions and allow you to prioritize your management strategies. A smart well field operates at optimal pumping rates to reduce energy costs, reduce aquifer depletion, manage contaminant plumes, reduce water treatment costs, etc. It also identifies when wells require maintenance and wells that interfere with each other. It calculates aquifer parameters and delineates wellhead protection areas, and it enables risk assessment and emergency response planning based on real data. And we'll get more into these later. So why this platform? Well, what we found over the years is that many well fields have been developed without a careful consideration of the local hydrogeology. More times wells are installed because the utility or operator already owns the property, or they want to site a well that is near the water treatment plant, or they're totally reliant on a well driller to tell them where to go to get some more water. But groundwater does move in a predictable manner that is governed by physics, mathematics, and chemistry. Well performance can be optimized when wells are designed, installed, developed, operated, and maintained properly to ensure that the aquifer is being managed in a sustainable and an efficient manner. Many well field operators already continuously monitor the well yield using flow meters. Fewer well field operators accurately monitor the water level in the well. By monitoring both, a hydrogeologist can perform numerous calculations to evaluate the well efficiency, well interference, entrance velocity, and capture zone of multiple wells. So here are the technology components. The hardware consists of pressure transducers. This is a pressure transducer up in the upper right here. It's just a stainless steel probe connected to a cable. Many of you also have a digital flow meter that is connected into another telemetry box, or this telemetry box, or your SCADA system. The telemetry is the relatively new component that has really made this technology viable and brought the costs way down. If you've got observation or monitoring wells that you're not pumping, usually there isn't power out to those wells, so we have a solar panel solution to drive the pressure transducer and the telemetry box. Many of you have variable frequency drives, programmable logic controllers, and kind of the new thing that's replacing the PLC is what we're terming an IoT controller. So with an IoT controller, a VFD, and our technology, you can be turning your pumps up and down and on and off to meet an objective that you set. So many wellfield operators already have some or all of these tools. The difference is the software side. We generally think that you need a cloud or a server-based database warehouse, and then you certainly need a groundwater data analytics and visualization tools, and that's where we think we differentiate ourselves. So we've developed what we think is the first ever real-time aquifer mapping solution. This is a picture of a well field outside of Sacramento, and what we've done is be able to stream water level and flow rate data, and using our analytics, we create a picture or a map of what's happening in the aquifer. In most cases, we color the screen with dark blue, meaning that's high groundwater, and the white or the lighter colors are low groundwater. So we'll get into this more later, but what happens when you turn a well on is that it creates what's called a cone of depression. So you can actually see which wells are pumping over time here by the lighter colors around the well, and you can watch wells turn on and off, and you can actually see then what's happening down in the aquifer. We think this is the truly revolutionary part of what we're doing, but we also have brought in the whole well hydraulics equations and the ability for you to determine if there's a better or cheaper way to pump water. So how do we manage your resource? There's numerous ways that we can specifically address the issues that you guys face every day. There's the drawdown in the energy consumption. There's the specific capacity, well efficiency, and entrance velocity. There's well maintenance and rehabilitation issues. There's well interference issues. There's the new well siting. When you have to put a new well in, where do you put it in, and how is that going to affect other wells? How is it going to affect your neighbors? Then there's the federally mandated programs, the Wellhead Protection Acts, the risk assessment, emergency response plan. In most states, there's a water appropriations permitting step. If you're going to put in a high-capacity well, you need to get a permit to do that. There's generally some annual reporting requirements associated. There's water rights issues, liability assessment issues, litigation issues. There's water treatment issues, and there's water use restriction issues. And we think that our technology directly addresses these and can do these things better and at a less of a cost for you. So an important concept to understand right from the get-go is what's called drawdown. When your pump turns on, the water level that was up here gets drawn down, and it creates what's called a cone of depression. And there is an aquifer loss component of that drawdown, and there is a well loss component of that drawdown. So pretty obvious that energy is required to lift the water, so the more drawdown equals the increased cost. Over time, as the well deteriorates, the borehole or the screen gets plugged, which increases the well loss component of drawdown, increases the drawdown, and then increases the cost of pumping the water. A couple more technical terms that set up the basis of what our technology is actually doing. Specific capacity is defined as the ratio of the pumping rate and the amount of drawdown. So if you're pumping at 100 GPM and the drawdown is 20 feet, then the specific capacity of the well is 5. 100 divided by 20 equals 5. So over time, the well plugging will decrease the specific capacity. Let's say you're still pumping at 100 GPM, but your drawdown goes to 50 feet. That would be a specific capacity of 2, and it would indicate that your well is getting plugged and it probably should have some maintenance done to it. We find that most operators do track their specific capacity, but we don't find a lot of operators who understand these next two terms in particular. Well efficiency is the ratio of aquifer loss and well loss. It can be estimated in some cases by performing what we call a step drawdown test, and I'll demonstrate this a little later. But you can pump at various pumping rates over time, and it kind of develops or it determines the sweet spot for each well, and it indicates if a well needs rehabilitation or redevelopment. Even less monitored by most operators is the entrance velocity. So if you can visualize what's happening down in the hole as you're pumping water, all this water is entering this relatively small borehole from around the aquifer. And so it's defined as the speed at which water is coming into the well. The reason it's significant is that as entrance velocities get higher and higher, it creates this plugging effect either in a borehole, a bedrock aquifer, or in a screened aquifer, and the openings in the screen or the openings in the aquifer get plugged with mineralization. And we haven't found a lot of people that know the specific capacity, the well efficiency, and the entrance velocity of any of the wells, let alone all the wells. And so our technology, by just installing a water level sensor and hooking up to your flow rate data, it allows us to go through your whole well field and determine these empirical numbers for these 3 parameters, and we can usually identify some pretty low-hanging fruit in order to save significant energy costs in the way that you pump water. So like I said, over time, the condition of the well deteriorates because the borehole or the well screen gets plugged with the mineral precipitation. We found that the well field managers generally rely on 3 different methods to decide when to redevelop a well. Probably the most common is a routine schedule. We ask our clients why they do it that way, and it's usually because it's always been done that way. The common schedules are 3, 5, 7, something like that, depending on obviously the geology and the hydrogeology of the area. We actually have had customers who fully admit that they pump their well to failure rather than spending the money on redevelopment. If they live in areas where shallow groundwater exists, perhaps a new well is just as expensive as a well redevelopment, so they'll pump to failure. It's also pretty common for a well contractor that probably installed the well or is their pump or well maintenance contractor, they'll call and say that it's time to do it. In our area of the country, up in the upper Midwest, our bedrock wells are generally between 500 and 1,000 feet deep, and it can cost over $30,000 to pull the pump, mechanically or chemically treat the well, perhaps do a well video at that time, and then put the pump back down. and bring the well back online. We think there's a much better way to do that if we can utilize the sensor data from the well, the water level sensor and the flow rate sensor, and in a lot of cases, water quality sensors. We can have a much more scientific way of determining when the well needs redevelopment. We've had customers who have purchased our technology simply for this reason, that it helps them to have a much better idea what the efficiency of their wells is and when it's time to redevelop. Certainly the return on investment of our technology is extremely quick. If we can come in and say there were 2 or 3 wells scheduled for rehab this year, if we can defer that cost, that can save many, many times the cost of the investment in the technology. Another common thing we see is well interference. We've run across lots of customers who they say, well, we can't run wells A and B or 1 and 2 at the same time. We're not really sure why, but we just don't. And it's generally because the wells are placed too close together. They create interference, or in this diagram, it's what's called overlapping cones of depression. Each well has its own cone of depression, but when they interfere with each other, it creates one big one, and the water levels go down much further in the aquifer than they would if the wells were pumping individually. So we've created a mathematical solution to this. We have a database tool that hooks up to the data stream, and it can go across your well field, and it will quantify the amount of interference that 1 well or 2 wells is creating on any other wells. And I'll demonstrate that. Another big important component is when you need new wells. Obviously, as the population grows in your area or your wells are getting older, you need to put new wells in. A lot of times, operators will spend a lot of money to develop a groundwater model that are used to help evaluate the effects from a new well. Unfortunately, these models are based on assumptions that never accurately depict a real aquifer. Our solution uses real data. Moreover, we learn over time, and we can really understand how the aquifer reacts by watching the effects of pumping and the effects of recharge, precipitation, and we can do this really at a fraction of the cost of a conventional consulting fee because the data are in a form to be analyzed immediately upon us leaving the installation. So wellhead protection, risk assessments, and emergency response plans. Most of you probably already know that there is a federally mandated wellhead protection plan for all public water providers, including both public and private water suppliers, schools, churches, rest areas. Wherever the public is drinking water, there are certain levels of wellhead protection plans that are required. Also, relatively recently, America's Water Infrastructure Act of 2018 requires municipalities and public and private water suppliers of different sizes to develop a risk assessment and emergency response plan. Well, hopefully it's obvious that the more accurate your wellhead protection area and the capture zone of your well, the more accurately they're depicted, it's going to save a lot of money in being in compliance with these specific acts. In most areas, if you're going to put in a well that can pump a couple hundred gallons a minute, you're going to need a permit from the local water authority or regional water authority to be able to do that. Oftentimes, these require aquifer testing and long-term studies, and believe me, we've been doing these for 30 years, and that's kind of one of the reasons we developed this technology, because our technology easily incorporates the wireless access to the pressure transducers and flow meters, and we're basically doing all the hydrogeology all the time. So once you install our equipment, you are always performing an aquifer test 24/7, 365. So water rights and liability assessments, litigation support. Obviously, water rights disputes and groundwater contamination lawsuits have traditionally relied on groundwater models that have assumptions that are rarely defensible. Large water users, including mining companies, irrigator, food and beverage processors, oil and gas companies, and public water suppliers, need to understand the potential liability of their water withdrawals. Superfund sites often contain many extraction and monitoring wells to remediate contaminant plumes. The correct placement of wells and long-term monitoring strategy are important for cost control and defensive decision making. Because we use real data and advanced hydrogeologic methods to continuously record the effects of your pumping, both yours and people outside of your well field, on the local and regional levels, our database tool is a user-friendly data analysis platform. For water treatment issues, we've talked about the minerals in the aquifer. In many places, especially in rural areas, we find the iron, manganese, and magnesium are generally not health related, but the staining and taste issues are major cost and customer satisfaction problems for water suppliers. Our technology can actually go around and evaluate the geochemistry of the well field. We can evaluate the optimal pumping rate to reduce water treatment. In a lot of cases, we can evaluate possible blending strategies, and we can perform a cost-benefit analysis of new wells versus water treatment issues. In some areas of the country, they actually enforce water use restrictions. We find that communities who don't totally understand their aquifer are kind of afraid they're going to deplete the aquifer especially this summer when a lot of residential and commercial and golf courses are irrigating, and so they go on to an odd-even lawn watering restriction. These restrictions are seldom based on hydrogeology, and obviously if you go on an odd-even watering restriction, you're reducing your revenues by, 50% during the periods of the watering bans. So what we do is, over time, the technology will learn, and it will give you a predictive tool that you can use to see whether the current climatic conditions, i.e. recharge or drought in some cases, are going to make a situation where you could lower the aquifer. But in many cases, the technology will give you the confidence that you don't need to do that. So what do you need to operate? We basically are leveraging the data from your existing SCADA system, or if you don't have a SCADA, it's very inexpensive and quick to install the necessary equipment to get you hooked up in the cloud. But for a smart well field, you do need water elevation data, pressure transducers or equivalent. There's lots of different methods of measuring water levels out there. We do need an electronic flow rate data. And these two things need to be streaming into a database either on your platform, your servers, your SCADA, or in the cloud, or both. Actually, we have customers who want that redundancy between their system and our system. In order to play, we need accurate elevations of the top of the well casings. One thing our technology does that we don't know of anybody else doing is converting the data on the fly to feet above sea level. So you can't make a contour map if all the wells aren't referenced to the same datum. So we need accurate elevations at the top of the well casing, and then we need to know how deep the sensors are. And finally, if you're going to have a smart well field, you do need to have the well pumps operate at different flow rates, either through a VFD or a valve. So we tap into the existing SCADA or mine the data. We calculate specific capacity continuously by dividing the flow rate by the feet of drawdown. We calculate well efficiency by doing a step drawdown test, and we can watch that over time. The well efficiency is the ratio of the aquifer loss and the well loss. We also can calculate the entrance velocity at various times during the year by looking at the open area of the well by the flow rate. So finally, the other two things we do, and probably this is the crux of what we're offering, is a potentiometric surface is interpolated using a nonlinear drift kriging algorithm to accurately visualize the groundwater across the well field. The potentiometric surface is just a fancy word for a groundwater contour map. But what we can do is we can combine these individual timestamps that, can be 1 minute, 5 minute, 15 minute, hour, day, doesn't matter. We can combine these into essentially a video that you can see how the aquifer responded over time to changes in pumping and recharge. And finally, we can calculate the well interference across the well field and create a matrix for you that will help you to determine what flow rates would prevent the interference. So with that, I'm going to jump out of the presentation here for a minute, and I'm going to demonstrate some of what we're talking about here. I'm going to kind of work backwards. We've been an Esri business partner for over 25 years, and we thought it would be a good idea to integrate our technologies into the ArcGIS platform. Those of you not familiar with this is a product from ESRI. It's called ArcGIS. They have different platforms. They now are supporting a desktop version called ArcGIS Pro, but they also have developed an ArcGIS Online and an ArcGIS Enterprise solution. We found that most of our customers have this program somewhere within their organization, usually the planning department. We haven't found a lot of water departments that are able to utilize this technology, and so we felt that since most organizations already have this, we don't need to recreate the wheel and create a GIS that you're able to zoom in, zoom out, change the base maps from streets to topographic maps to aerial photos, and we generate these potentiometric surfaces in a package we called Aquimetrics. But by being able to export these maps, we found that it's very useful for communication amongst the project teams, public education, city council meetings. Once people understand that these different colors represent different groundwater elevations, most people kind of understand that groundwater flows from high levels to low levels, and so the darker colors represent higher elevation. So this gives you a pretty good picture of what water is doing. For our demo, we've been working with communities in the southwestern area of Minneapolis for many years, and so we've been able to get data from several different municipalities and look at those water levels as a whole, really regionally for the first time. We don't know of a lot of other areas that are doing this right now. So this is just the ArcGIS component. So how do we generate these images? We have another package that comes with our technology. It's called Epiphany. And we built this because if you have a database, it's very difficult sometimes for people who don't know how to manipulate a database to get in and actually look at the data. So we created this hopefully relatively simple application for non-database people to come in and look at groups of wells or individual wells. We have, you can look at individual parameters or groups of parameters. In this case, we're interested in the groundwater elevation. And you can also select a time period, and once you have what you want to see as far as locations, parameters, and time, you can hit the graph button, and it works relatively quickly. This is what was happening in the Southwest Metro over this time period. And we've made this graphing tool so you can toggle between stack graphs or individual graphs. I like to show this because it's almost like a Jackson Pollock painting. How could you possibly evaluate which wells are influencing other wells? So the same data set that you're looking at here has been analyzed using our third package that I'll demonstrate. And this is really the heart of our technology, and this is called Aquimetrics. So this is where the heavy lifting is done to be able to look at groundwater in a much different way than has historically been done. So again, this is the same data set that we were just looking at in the graphing package, and this is what we call our current conditions window. This is a potentiometric surface or a groundwater contour map across the well field in this particular time period. Now, these 3 municipalities, they collect data at different frequencies. So obviously we can't interpolate data that hasn't been collected. So what I'm going to do is go in and kind of go under the hood for you. And this is totally user manipulative. You can come in and you can look at different wells. If I wanted to take wells out or put wells in, you can come in and create your own well groups. You also can configure all of the extensions. So for the current conditions, I want to see all the 2020 West Metro wells. I want my colors to be 10. I want to start, I'm going to change this. Well, it looks like it just refreshed. And so it came out to a time period where they had all the wells. For the historic analyzer, I kind of like to crank the colors down, and we can decrease the cell size so we get a much crisper map. The well interference tool that I'll demonstrate in here for a minute, what I've said is in order to evaluate interference, I want to see a change by 1/10 of a foot within 5 minutes of a pump turning on. But you can obviously change these depending on the type of aquifer that you have. So I'm going to save this, and it's going to come out and refresh. While it's refreshing, I'm going to go in, and this is the historic analyzer component. And with this, I'm going to resize the window to fit the well field. I'm going to say I want a West Metro well. I want to see the minimum amount that the aquifer drew down over a day between May 1st and May 6th. So I'm going to start, and it's going to say we're going to do 6 for you. Would you like to proceed? Yes. So this is where the mathematics come in. Now it's taking the actual water levels and flow rates from all those wells, and it's using a relatively sophisticated algorithm to generate these pictures that, again, show which wells are pumping, which wells aren't, and how the water between those wells is behaving. So we talked about this concentric circles or the cone of depression. This well just turned off. This well is on. This well is on. And so over time, it's building these animations so you can see over time whether your well was affecting other wells, but maybe more importantly, where water is coming from and where it is going. So once you're through with the simulation, you can either play it on screen, you can export it as an AVI and send it or play it for a public education meeting or a city council meeting. You can also export an individual map as a map, and that's the one that I showed you that was in the ArcGIS platform. So this is what we call historic analyzer. The well efficiency tool, if a lot of you have variable frequency drives or have valved on wells on your wells, what we do is we work with you, and you can run what's called a step drawdown test. And it's called that because if you increase your flow rate incrementally over maybe at night, maybe between 2 and 6 in the morning, you can run this test. You might do it once or twice a year, but what we've done is we've embedded the mathematics behind this graph. And so if I right-click and I come to the bottom of each step, and I would do this more carefully, obviously, if this was real, but for demonstration, what we've done is embed the math behind here so you can quickly come in and look at the well efficiencies. So you can see that here's your aquifer loss component, your well loss component. Here is the well efficiency, and you can see that it started out at about 55% efficient, but went down to about 30% efficient after the last step. And so this well would probably be a good candidate for some maintenance or some rehabilitation. So that's kind of the well efficiency tool. There's lots of other graphs and metrics that we've included, but I'll skip through that. Our well interference tool is what I was talking about, how you can go through and you can look across your whole well field as to which wells interfere with other wells. If I choose all the wells and I choose an observation well, a specific observation well, it's going to go and it's going to get all the data, and with the click of a button it's going to go in and it's going to see time periods where wells that E16 appears to possibly be affecting this SLP10. And so by clicking through, you can quickly go through and either evaluate whether it is something that did it or not. And you can go through the entire well field to do that. Once you find out wells that interfere with other wells, you can then make corresponding schedule changes to make sure that the drawdown is not increasing significantly and costing you more electricity. But this can be a pretty handy tool because it would take hours and hours and hours to try to go through that same pumping data that I was showing over in Epiphany to evaluate which wells have effects on other wells. So that is the well interference tool. The last module is our specific capacity module. A lot of folks are already doing this. We've just, again, made it very simple by mining your SCADA data or our telemetric data. If I choose any pumping well, it's going to go out to the database and it's going to get the data. Those of you who are well field managers, you'll recognize this as a pretty standard hydrograph of a well that has been turned off, turned on, turned off, turned on, and very common schedule. This looks like this well pumps once a day for maybe half the day. So by right-clicking at the top and setting the pumping level, static level, excuse me, and then right-clicking on the pumping level, it goes to the database, it knows the flow rate, it knows the drawdown, so it knows the specific capacity. And if you save this to the database, then over time you can watch the specific capacity of all of your wells, and we can help you to send an alert as to when one well appears that it may need some maintenance or some rehabilitation. So again, the four modules are the current conditions of what is actually happening in the aquifer now. The historic analyzer shows you what happens over time. The well efficiency module shows you whether your wells could stand some redevelopment, as well as the specific capacity tool. And the well interference tool tells you if there's some low-hanging fruit in changing your flow rates or your schedules to reduce the overall drawdown within your aquifer. The other thing that I didn't point out here on the current conditions is the particle tracking. So this is how we can, over time, look at a particle and where it would flow over time. Your wellhead protection areas and your wellhead delineations are based on this exact picture. Here's a great example. It just scrolled through the data, and we're looking at these concentric circles, and you can see how these particles are moving into the well. These are truly vectors, so the length of the arrow is the velocity of the water. So we can ask this to do it at any time period, both looking forward and looking back, and this is how you can generate a fairly accurate capture zone in a 10 or 20 year time of travel for your wellhead protection planning efforts. So in summary, we've gone through and demonstrated how we can create aquifer maps with particle tracking capabilities in both real-time and continuous time. We demonstrated how we perform a step drawdown test to calculate well efficiency. We demonstrated how to go through and make a complex query through the database to identify wells that interfere with other wells. And we demonstrated how to calculate specific capacity for any well in the well field. We've also have the capability to make custom screens for your telephone or your iPad, tablet PC, and really we can bring data from a data feed into any kind of platform that you or your employees would like. This one in particular shows that the pump is running, the flow rate is 800 gallons per minute, the VFD is set at 58 hertz, the current temperature of the water is 75. We can also color these and put warnings and graphs if there's something wrong in the well. We also show the drawdown, the feet above the pump intake, and warn you if that's getting close. We also can caution you if the specific capacity of the well is going down too fast. This screen kind of shows a drawdown monitor. This would indicate that maybe the aquifer is getting depleted because you can see that the well doesn't get back to where it was originally. It also shows that there might be some better pumping schedules. It's hard on the pump when the pump is turning on and off and on and off. In this case, if they lowered the flow rate and increased the amount of time they were pumping, they would probably significantly reduce the drawdown and therefore save electricity. Some of the economic benefits that we see in installing our technology, first and foremost, is we guarantee a 10% reduction in the total drawdown across the aquifer, across your well field, or the technology is free. We also estimate that you could save about $30,000 a year in maintenance savings if you were redeveloping wells that don't need to be redeveloped. We think you could see a significant decrease in the amount of fees that you're spending to develop wellhead protection areas. We can also see a potential revenue increase if you are needlessly enforcing water use restrictions or you're managing wellhead protection areas that are much too large. But at the end of the day, I guess we see that extending the life of your aquifer is really what this is all about. What does it cost? We charge $100 per well per month for the license fees to be hooked up to the cloud-based aquifer resource management system. The average installation costs for the instrumentation, if you don't have them already, that's come way down over the years. We are averaging about $1,250 per well for the transducer, the cable, the telemetry, and the labor to install it. We also have a couple optional services that include a well field health analysis. Once we see how you're pumping for a month or two, we can develop a written report or a virtual meeting with you and your staff, and we'll go through and make recommendations on each individual well, looking at the specific capacity, well efficiency, entrance velocities, well interference, and that generally runs about $3,250. Another optional service is the ongoing consulting services. A lot of our customers like the fact that we can produce a monthly newsletter type form, either in electronic format or paper format, that shows all of the metrics across the well field with graphs, histograms, bar charts, pie charts. We can alert you to any instances of improvement that we identify across your well field. Finally, the maintenance is another optional task. You can do it, we can do it, but really somebody needs to go in at once a quarter and clean the sensors, calibrate the sensors, and make sure that everything is running properly. We see an average annual investment of approximately $1,200 to $4,250 per well per year. Certainly we feel that the payback on this could be anywhere from weeks to months, but in the end, the technology essentially pays for itself. If you need to contact us, you can contact me at that cell phone number and that email address. You can also contact Jeff Solheim at that telephone number and email address, or you can visit our website where you can download a copy of this recorded webinar. So thank everybody for coming today. Thanks for your attention. I hope I've answered most of your questions, but with that, I'll open it up to questions for everyone. Thanks again.